Now we will see circuit element. To get these notes, you can visit this website link electrical-engineering.app. Here you will get educational contents, notes, MCQs related to electrical and electronics engineering. Check the link in the bio, or you will also get the website link in the video description. Now let's see what is resistor. So first of all, a resistor is a small electrical component used in electronic circuits to control or limit the flow of electric current. Now here we can see it is a passive component. Now the resistor does this by providing resistance which reduces how much current can pass through it. So it opposes the flow of electrical current. Now resistance is denoted by capital R. Now what is resistance? So resistance is the property of any material or component that opposes the flow of electric current. It tells us how hard it is for current to flow through. The unit of resistance is ohms, and it is denoted by this symbol omega. Now here we can see 1 ohm is equal to 1 volt divided by 1 ampere. Now here we can see linear VI characteristics or linear VI relationship in both AC and DC. Here we can see this is the VI characteristics graph for resistor. Here on x-axis we have taken voltage, and on y-axis or on vertical axis we have taken current. Now here we can see on first quadrant and third quadrant the graph is same. That means the resistor is linear. It is a linear element, and also it shows linear VI characteristics in both AC and DC. Now resistor dissipate electrical energy. Now next we will see, here we can see this is the symbol for resistor. Here this is current I, and this is the voltage across this resistor, and this is our Ohm's law. I is equal to V upon R, that is current is equal to voltage divided by resistance. So this is the Ohm's law. Now for this resistor, power absorbed is equal to P is equal to V into I. Now remember that the resistor absorbs the power because it is a passive element. So power is equal to voltage into current, and it is equal to, we can also write the formula for power as V square divided by R, or we can also write it as I square into R. Now we can generate these formulas by using this relationship, that is current is equal to voltage upon resistance. So if we put here I is equal to V by R, then we get this formula. Or if we change the value from this, if we put V is equal to I into R, then we get this formula. So we can interchange these by using this relationship, and we get different formulas for power absorbed by resistor, and the unit will be watts. Now next we will see the mathematical expression for the resistance of a conductor is, here this is the formula for resistance. So resistance R is equal to rho L by A. Now here this R represents resistance. Now here this rho represents resistivity of a material, and it is constant. So this resistivity is constant. Now this L represents length of the conductor, and this A represents cross-sectional area. Now let's continue again resistance and resistivity. So here we can see this is the material, and the current through this is this current I, and the unit of current we know that it is ampere. Now this is the cross sectional area A, and this is the length which is represented by L. So for this material we can write its resistance will be like this. Resistance R is equal to rho L by A, where this rho represents resistivity and its unit is ohm meter. This L represents length and this A represents cross sectional area. Now here power is equal to voltage into current. Now here also this resistance is directly proportional to its length. That means if we increase the length, then resistance will increase. Also, the resistance is inversely proportional to cross-sectional area. That means if we increase the cross-sectional area, the resistance will decrease. Now here resistance is represented by R and its unit is ohm, which is represented by omega. Now let's move forward. Now here we can see resistor. So lower the flow of electric current. What does resistor do? It lowers the flow of electric current and regulates or limit flow of electrical current. So this is the work of resistor. Now here is the definition we can say. So a device having resistance to the passage of an electric current is called as resistor. So this is about resistor. Now again here we can see the symbol for resistor. So this zigzag line are called as resistor. Now here we can see it is a passive component. It has two terminals and it is a passive component. Now here we can see fixed resistor resistance changes slightly with temperature, time or operating voltage. Now even though this is a fixed resistor, but its resistance slightly changes with respect to temperature, time or operating voltage. Now used to reduce current flow, this resistor is used to reduce the current flow or to adjust signal levels. Resistor is also used to adjust signal levels, or resistor is also used to divide voltages, or resistor is also used to bias active elements. So these are some uses or applications of resistor. Now here we can see value of resistor can be measured with an ohm meter. Now if we want to measure what is the value of this resistor resistance, so we have to use ohm meter. Now let's move forward. Here we can see high power resistors dissipate many watts of electrical power. So the high power resistor will dissipate more electrical power. Now again here we can see Ohm's law is equal to V is equal to I into R, where this V represents voltage in volts, I represents current in ampere, and this R represents resistance in ohms. Now again the formula for power, which is represented by P, is equal to I square R. Now here power unit is watt and this R represents resistance and its unit is ohm, which is uppercase omega. Now remember that there are two types of omega, one is uppercase and one is lowercase. So this is the uppercase omega. Now here resistance is the property. Resistor is an element and resistance is the property of an electrical component to resist the flow of electric current. So remember that resistor is different. Resistor is actually an element and resistance is the property of an electrical component to resist the flow of electric current. Now here again the formula for power is given. So power is equal to V into I, that is voltage into current, and it is equal to V square divided by R. Now again here are some symbols for resistor. So this is the symbol for fixed resistor we can say. Now here, this is the symbol for variable resistor, or we can say this is a rheostat. Then next is, this is the symbol for potentiometer. Now, when we connect resistors in series, here we can see these resistors are connected in series. R1 is in series with R2, and we can connect up to Rn. That means we can connect n number of resistors here. Now their equivalent resistance will be, or we can say their total resistance will be, Req is equal to R1 plus R2 plus up to so on, up to Rn. That means when resistors are connected in series, we have to simply add them. Now what will happen when the resistors are connected in parallel? So here we can see R1 is in parallel with R2, and R2 up to Rn. We can connect multiple number of resistances in parallel. Now here one more thing, remember that when resistors are connected in series, that time the total resistance increases. Now if we connect the resistors in parallel, what will happen? The more number of resistors we connect in parallel, their total or equivalent resistance will decrease. Remember this point? Now here we can see when the resistors are connected in parallel, that means their equivalent resistance will be this formula 1 upon Req. Now this Req represents equivalent resistance. So 1 upon Req is equal to 1 upon R1 plus 1 upon R2 plus up to 1 upon Rn. So this will be, by using this formula we can calculate equivalent resistance. Now here, this is how a resistor look like. Now there are different types of resistor. So this is one of them. Now here we can see this is a circuit board, and on this circuit board, this is a resistor. Also remember that there are different types of resistors. So some resistor look like this and some resistor look different. So here also these two are resistors. Now here we can see this is a network of resistors. So here there are many resistors connected in, some are connected in series. Here we can see R7, R8, R9. These are connected in series. Now they are connected in parallel with this R5. So this is the network of resistors, or we can say it is a resistor network. Now we will see example applications of resistor. So number one example application is LED current limiting. So as we know that resistor is used for limiting the current. So here in this circuit we are using this resistor for limiting the current through LED. Otherwise what will happen, if we give more current than rated current to this LED, then this LED will burn out. So to avoid this, we will use resistor. Now to calculate the exact value of this resistor, we use some formulas. Now here we can see the voltage drop across this LED is 1.8 volt. It is a forward voltage and it is in red color LED. Now LED stands for light emitting diode. So this is how the LED is connected. Now here we have a battery of 9 volt, or we can say it is a source voltage Vs. Now here the resistor is connected in series. We have to connect the resistor in series with LED to limit the current. Now if we increase the value of this resistor, then the current will decrease. And if we decrease the value of resistance, then the current will increase. But we need proper value of current to get the proper lighting of this LED. Otherwise what will happen, if we give too much resistance, then the LED will not glow. And if we don't give any resistance, that time maybe what happen, this LED will burn out. So here maximum forward current is around 20 milliampere for this LED. So what we have to do? We have to use this formula. Resistance R is equal to Vs, that is source voltage, minus Vf, Now this Vf is LED's forward voltage. Now this forward voltage and this current, these are decided by manufacturer of LED. So these are the ratings of LED. So by using these ratings, we can calculate the value of resistance. So here the value of Vs is source voltage minus Vf, that is LED's forward voltage, divided by IF. Now IF is the LED's forward current. So these two are given on the LED rating. So if we substitute the value of Vs, which is 9 volt, minus LED's forward voltage, which is 1.8 volt, and divided by IF, which is 0.010. So the resistance will be around 720 ohm. So that's why we are connecting this 720 ohm resistance in series with LED. Now we will see the next application of resistor. So we can also use resistor for voltage dividers. So here we can see a voltage divider is a resistor circuit. A voltage divider is a resistor circuit which turns a large voltage into a smaller one. Again, a voltage divider is a resistor circuit which turns a large voltage into a smaller one. Now let's understand this from this circuit diagram. Here we can see we have a voltage source of 9 volt. But suppose we only want 3 volt. So what we will do? We will connect two resistors in series. Now the value of this resistance will be like this, 2 kilo ohm and 1 kilo ohm. So from here we will get 6 volt output, and from the voltage across this R2 will be 3 volt. Here, to calculate the voltage across this R2 resistance, we use voltage division rule. Here we can write, we have to use voltage division rule. So by using this voltage division rule, we will get VL is equal to Vs into R2 divided by R1 plus R2. So this is nothing but the voltage division rule, and by using this formula we get the voltage across this R2, and which is 3 volt. So this is how we can convert a large voltage into smaller one. So this is one more application of resistor, and there are more application of resistors. So this is about circuit element resistor.